Today we're going to solve equations that involve fractions. There's a couple different ways to do this, and I'm going to try to give you the easiest method for each type. So, in this first example, do you notice the denominators are all numbers? If the denominators are all numbers, let's get those numbers to match. Think about 2, 3, and 6. What number should we kind of aim for? 6. We can make 3 turn into 6. We can make 2 turn into 6. So I am going to, first I'm going to space this out a little bit because I don't like how close this is written. All right, if I want to turn this 3 into a 6, I would have to multiply by 2. And if you multiply by 2 on the bottom, you have to also multiply by 2 on the top. If I want to make the second one, the 2, become a 6, I'd have to multiply by 3, which means we have to multiply the top by 3 as well. And then this last one is already 6. So now we have 2x squared over 6 plus 3x over 6 equals 5 over 6. The denominators are all 6. When you're adding and subtracting fractions, you have to have common denominators. You don't change the denominator, but you add the tops. So what this basically means, if you've got something over 6 plus something over 6 equals something over 6, what you basically have is 2x squared plus 3x has to equal 5. So we have the equation 2x squared plus 3x must equal 5. If the denominators are all 6 and there's no x on the bottom, the tops, you can just use the top as its own equation. Now, how do we solve this kind of equation? We are going to have to get one side equal to 0. And factor and solve. And I do want to remind you how to factor when there's a number in front of the x squared. Do you remember how to factor when there's a number in front of the x squared? We have to multiply the 2 and the negative 5. So we are looking for a pair of numbers that multiplies to give us negative 10. That same pair of numbers has to add up to 3. 1 times 10 wouldn't do it. 2 times 5. If it's a negative 2 and a positive 5. Because there's a number in front, we either have to do factoring by guess and check or we have to do factor by grouping. Some of you prefer grouping. You take your 2x squared. This 3x splits into these two numbers. So negative 2x plus 5x minus 5. So we split that 3x into the two numbers that we found when we were factoring. And now we have to split this down the middle and factor by grouping. What does the first group have in common? 2x squared and 2x. They have 2x in common. 2x squared divided by 2x is just x. What is negative 2x divided by 2x? Negative 1. What do 5x and negative 5 have in common? 5. And that would leave us with x minus 1. So our factored form is 2x plus 5 times x minus 1 equals 0. All right, this part's easy to solve. What number minus 1 will give us 0? 1. So one of our solutions is 1. For this other one, we need to do 2x plus 5 equals 0 and solve that equation. to get x equals -5/2 or -2.5. Our two solutions are -5/2 and 1. Okay, now normally if you do this type of a problem, the hardest part about this problem, I think, is this factoring and solving part. Usually the factoring part is easier and doesn't take quite so much work. So this type of problem, if you see that it's just numbers in the denominator, get those numbers to match, and then the top gives you the equation that you need to solve. Let's move on to example 2. On this problem, we could try to get common denominators and then maybe cross multiply two fractions. But the easier way is to eliminate the fractions, make the fractions go away. If you want to call this fraction killing, you can, if that makes you happy. But we are going to make the fractions go away. To think about how to make the fractions go away, I want you to think about what denominators do you see in this problem? Basically, what factors do you see in the denominator? What things are being multiplied together in the denominator of this problem? There's a 3. There's an x. And what is this 3x really? It's 3 times x. So in the denominators, we have a factor of 3 and we have a factor of x. And then some combination of that. I want you to multiply everything by those denominators. So I'm going to multiply this first term times 3x, the next term times 3x, and the next term times 3x. You don't have to multiply the top and the bottom, you just have to multiply the top because you're multiplying every single thing in the equation by the same thing. If you want to know why we can do this, think about the equation x plus 2 equals 5. If I multiply every single thing in that equation by 2, we would have 2x plus 4 equals 10. The solution is still 3. We haven't changed the equation, we just changed how it looked. So we're multiplying every term, just the numerator, by the 3 and the x. Okay, here's the fraction killing part. In this first term, the 3 on the bottom cancels out the 3 on the top. Because we're multiplying, we are able to cancel out common factors on the top and the bottom. So what's left here? 8x equals. In this next term, the x on the bottom cancels out the x on the top, and we're left with 7 times 3. What is 7 times 3? 21. Minus. The 3x on the bottom cancels out the 3x on the top, and we are left with 1. Does 8x equal 21 minus 1? Does that look simpler than whatever we started with? Absolutely. So this means that 8x equals 20. What should we do to finish solving this? 5 by 8. We could either simplify the fraction, or we could divide it in our calculator. If we simplified the fraction, I believe we end up with 5/2. If you put it in your calculator, you get 2.5. I would accept either one. I don't think you're going to run into it today, but we should mention, once you get your answers, you should check your answers in the original denominators. If we had gotten the solution x equals 0, and we tried to plug that in, this denominator would end up equaling 0, and you can't divide by 0, that's bad, so then that solution wouldn't work. So once you get your solution, glance at your denominators and make sure that your solution wouldn't create a 0 in a denominator. We'll get into that more tomorrow because I think we might encounter that tomorrow. All right, let's try example 3. Okay, we need to talk about factors in the denominator. X plus 2, that is a factor. You need to contain x plus 2 with parentheses. Anytime you see addition or subtraction, contain that whole thing with parentheses. What factors do you see in the denominator? Anyone? No? I see x plus 2. What else do you see? X and 5. We're going to multiply everything by 5 times x plus 2. And this one's a little bit tight, so I'm going to take a minute and space this out. Once we've multiplied everything by 5 and x plus 2, now it's time to destroy the fractions. In the first term, x plus 2 cancels, and we're left with 3 times 5 times x. What's 3 times 5 times x? 15x. In the next one, the x cancels out the x. We're left with 1 times 5, which is 5, times the quantity x minus 2. So we have minus 5 times the quantity x plus 2. In the third one, the 5x cancels out the 5x, and we have 1 times the quantity x plus 2. What do you suppose we need to do with that negative 5? Distribute. So take a moment, distribute, finish solving, see if you can get your solution. Okay, let's look at example 4. This one's a little bit easier. What denominators do you see? Just x minus 2. So you're going to multiply all 3 terms by x minus 2. Give this one a try on your own. So if we multiply every term by x minus 2, in the first one, the x minus 2 cancels, so we just have the 5x left. In the next one, there wasn't a fraction to begin with, so we have 7 times the quantity x minus 2. And then in this last one, we have the x minus 2 cancels, so we have 10. When we distribute the 7, combine like terms, get all of our x's to one side, we end up with the solution x equals 2. Does anyone see a problem with the solution x equals 2? If you go back to the original problem, the very, very original problem before you did anything, if I were to plug 2 in right there, what is 2 minus 2? 0. So you'd have 5x over 0 equals 7 plus 10 over 0. We can't do 5x divided by 0 or 10 divided by 0. You can't do math when there's division by 0. So this solution doesn't actually work. And if our only solution doesn't work, what does that mean for the problem? No solution. All that work just for no solution. Example 5 is not in your notes. We are going to do this together tomorrow in class. I'll do another video on that problem. For this assignment today, I would like you to do these 3 problems. When you get to this problem, I want you to write this problem down. Simply so we don't have to pull out the book tomorrow. You already have it written on your paper. So write this one down on your paper, but save it for tomorrow. So tomorrow we will start by doing number 36 together in class. Then we'll do example 5. I'll just have you add that to your work on your paper, and then I'll have a worksheet for you to practice tomorrow.